Alright, chapter 14 talks about soils. And the first part of this chapter talks about this term called desertification. And it basically means like how it sounds, taking a fertile area and turning it into a desert. And that tends to happen when you remove or damage the soils of an area. So first let's look at how soils are formed. And there's a great diagram down here that shows you the process of how soils are formed. So you have an interaction among parent material, bedrock, climate, organisms, time, and topography, and topsoils can take 2 to 1,000 years to form. So first we have our parent material, this bedrock area, and with this weathering process of the climate or possibly organisms or whatever it might be, wind, you start to break up that parent material, and when it's broken up and there's spaces in between, pioneer species can form. And remember back from chapter 5 with succession, you have succession that can take place. So as these organisms come in, these plants, and they grow and thrive. They live and die. They decompose. You start getting organic material within this weathered parent material. And the more weathering that you have, and the more organic matter that grows and dies and decays, you start to build what is known as soils. A lot of the parent material gives the soil its minerals such as nitrogen, potassium, calcium, or phosphorus, I'm sorry, not potassium. Potassium's here. Calcium, magnesium, sulfur, chlorine, lead, manganese, copper, and zinc. And that material is broken up in smaller bits by that weathering process, and plants can then absorb them for their mineral wealth. So here is a nice diagram showing the process of how soils are formed. Soils are made up of a couple different things. Major component is that mineral wealth from the parent material, 45% of it. And then you have 25% water, 25% air, and then breaking down into the smaller bits, this humus, which is decayed organic matter, roots, and then organisms make up the smallest portions of that remaining 5%. So, air, water, mineral, organic matter. Those are the main 4 components of soil. Inorganic matter, like that mineral, is broken into 3 sections. We've got sand, silt, and clay. Sand is the largest particles, ranging from 0.05 to 2 millimeters in diameter. Then going down you have silt, and silt, the texture of it and the size of it can be related to the texture and size of flour, cooking flour, and the particle size of flour, and that ranges from 0.002 to 0.05 millimeters in diameter. And then the smallest particle is clay, and those are particle sizes smaller than the 0.002 millimeter diameter. The organic is made of plants, animals, fungus, and microorganisms. I got this microrrhizia here, which, if you remember back from chapter 4 or 5, I'm not really sure, can't really remember, but microrrhizia is a type of fungus, I believe, that helps transform nutrients from soil to a usable form for plants, and helps the roots for plants. Humus, partially decayed organic material in soil, gives it a brown or black in color. Alluviation, which is deposits of minerals into lower soil layers from higher layers as a result of leaching, which we'll talk here in a little bit. And leaching is this term, actually I'll talk about it now. Leaching is where you get things going from a higher soil level to a lower soil level. You have deposits, which are accumulations of minerals in soil. And then leaching, here we go, movements of water and dissolved minerals downward through soil. And then last but not least, casting, which is bits of soils that have passed through the guts of earthworms that helps break up that organic matter. And they deposit them on the soil surface. As you dig down into soil, you have what is known as different soil horizons. And you can see this, we saw this in diagrams before, and I'll point them out in future slides. You can see these different layers, these different horizons. And they're broken up by this lettering that represents a different section of soil. So the first soil you have O horizon, or the organic horizon, which has the most organic material. And then below that you have the A horizon, and this also has organic and minerals combined. Deep rooting encourages growth and enhances organic carbon in the subsoil in this area. You have the B horizon, and then C horizon, which is the weathered material, and this tends to have the most mineral wealth, that is right above the bedrock. And if you're a fan of the show Gold Rush, you'll see that they always try to dig down to the C horizon, which is right above bedrock. And they try to get above that bedrock because that's where gold deposits tend to accumulate. So here we have some real examples of soil profiles. Sometimes soil profiles can be condensed and small and easy to dig down to, and other times they can be extremely deep. So here's a nice example. You've got your O layer up here, and then the first form starting of the A. Remember, O is organic. A is the mixture of organic and mineral. And then as you go down, B, and then finally C, where you're getting down closer to bedrock. Here we got a bigger O layer, and then you get into A, and then B. They call this the A, B, and then C down here. Here's another one to do as well. Very little O, and then A is this. This O is the very black color here. A is this grayer color here, and then you got B and then C for this one.